I'm Craig Herndon.
And I'm Neil Gupta.
And you're listening to the second episode of the Virtuality podcast, hosted by Boston Virtual Reality and Boston Augmented Reality. So today we actually have a guest from Qualcomm, which is a $23 billion company as of 2016, with over 30,000 employees, and was also founded by MIT and Cornell alums. And what are these 30,000 people doing is kind of what the question is today. And what's the thing that they're up to? So Nigel, you guys can introduce yourself.
Okay. I'm Nigel Williams. I currently work for Qualcomm as a senior software engineer. I do all the virtual reality feature development for OpenGLES and Vulkan. I'm actually originally from Newfoundland, Canada, and I went to the University of Waterloo in Ontario and also the Memorial University of Newfoundland. And I moved down to San Diego, where the headquarters is located, 4 years ago. And I spent about a year there. And then after that, I decided to move closer, to be closer to my family. My sisters are up in Toronto. And so I moved to our office out here, which happens to actually house our core graphics software team. So the software user mode driver for the Adreno GPU, which is a part of our Snapdragon system on chip.
So we're really glad you come on the show today. So Nigel is actually a Boston Virtual Reality member. And for the longest time, we were like, what are you working on? He's like, I'm just doing VR stuff. I can't talk about it. And it's every month is like, can you talk about it now? No. For years. And just recently in November, we were finally able to bring him into Boston VR and actually got to try out the Snapdragon headset before it hit CES and became its darling of the show. So congratulations on that.
Yeah, we're really happy with the positive reception and feedback from media.
So what can you tell us about Qualcomm's HMD program?
So right now we've released a software development kit, and there's also a hardware accelerator program. And things are just starting to come along and get a little bit more fleshed out. But the main tool set is a software development kit that developers can use to design their software and applications for a lot of the features that take a lot longer to come out to commercial devices. So our intention is just to progress the innovation in virtual reality as fast as possible. And commercial release cycles restrict that somewhat. Because there's a lot of barriers to entry for new features, whether it be performance or power consumption or for any numerous reason. And so we're doing everything we can to incorporate as many features that give you the performance to give you a truly immersive virtual reality experience, and at the same time alleviate the power consumption so that you can have a prolonged experience. And that's really the part that Qualcomm really performs at. It's called the power per watt. And that's something we accelerate at, that's something that we're very proficient at. And it's very important for VR in terms of performance, and a lot of the features that we're implementing facilitate that performance in virtual reality. Particularly, preemption would be the biggest one that I would say. And hardware preemption was first introduced by Qualcomm through our Snapdragon processor. Having access to the full system on chip, it makes it a little bit easier to design. And there are specific granularities of preemption, but I can't go into detail about that. But
yep.
The preemption itself is one of the main features that was required for asynchronous time warp.
Oh, I see.
And for that to actually happen, you need to properly preempt the iBuffer rendering. And to do that, you need to have hardware preemption to have a truly very low latency preemption of the application, and then scheduling of that process, of the asynchronous time warp process, to then present to the display. And there's a lot of features like single buffer, front buffer rendering, which I implemented to facilitate the very low latency motion to photon experience. And so basically erasing the raster. So that's what it provides. unfortunately, front buffer rendering is very going back to the dark ages of like OpenGL
Yep.
and graphical rendering, but it's required for VR so that we can minimize the latency as much as possible.
Right. And for those listeners who aren't techies, do you want to try and summarize that in layman's terms?
So what happens is that we paint the screen as fast as possible. And so instead, you have just like if you're watching a video, you go from frame to frame. And when that motion changes, you need to do it in such a way that you're not seeing both frames at the same time. And when you do that, you get artifacts and corruption. And so you have to render as fast as possible, but just not too fast.
Right.
So Nigel, I'm curious, when I look at Qualcomm, it's really interesting to me that they would put out their own headset because it looks like historically Qualcomm has been a provider to other systems as opposed to making their own sort of consumer-facing hardware themselves. Is that true? And if that is true, were you at all part of those conversations internally, or does this represent sort of a change in how Qualcomm is making products in any way?
Our intention is for our partners to adopt these features. And we want to accelerate that process as much as possible. And an easy way or a way to alleviate the barriers to entry is to have the design for the features finished earlier so that developers can begin working on these features at an earlier stage so that when the hardware features are available, they can immediately release them for the commercial releases.
So it's really to prime development beforehand.
Yeah, exactly.
So that's really interesting. You hear about different ways of people sort of trying to accelerate their own ecosystem. So how does, I guess from Qualcomm's perspective, if one of the headset manufacturers sees that from this device that Qualcomm is making and providing to developers or making available to developers, if larger manufacturers say, hey, it looks like developers really like components X, Y, Z, maybe we should roll some of those out. And then they'll say, okay, it looks like Qualcomm is the expert at creating the hardware required for X, Y, Z. Is that sort of the goal?
Absolutely. Qualcomm has been known to be purely a hardware vendor, and to partner with OEMs to release their commercial systems and to use our system on chip in their systems. We have to prove that they are the most capable and advanced technology is incorporated in the design.
So I'll step back to the previous question I was at earlier, which was, so you mentioned that Qualcomm wants to have a longer user experience. So when I tried out the Snapdragon headset, I noticed how light it was compared to the Vive or the Rift, which actually made it pretty awesome. So the other thing I want to ask about is that's really interesting about the headset is the way it's doing tracking is inside out. Is that correct?
Yeah, that's correct.
So I know Oculus and Vive are headed that direction. So is your design maybe not, but potentially would be something that if they're trying to put your chip in their headset to get that feature, that they would just use what you've already made, or how does that work?
We would definitely want our designs to be forward-looking so that people definitely adopt our technology instead of alternative implementations. So our intention is to make sure that our designs are the implementation that is selected for consumer versions. And particularly for 6-DoF tracking, that's something that we really wanted to get integrated into headsets because of purely 3-DoF experiences. So I should emphasize that. So by DoF, I mean degrees of freedom. So you can move your head in any kind of orientation, and current commercial devices allow the movement of the head in orientation, but it doesn't allow the displacement of position. So if you move around in a space, you're unfortunately not moving around in your virtual environment, and that removes you from the immersion of the experience. So really you want to make sure that, or one of the features of the inside-out tracking is that you aren't, if you have a multi-user experience, then another person who is tracked by, we're both being tracked by outside-in tracking, and that means your camera is looking at you and tracking your position versus the opposite, where the camera is on your device looking out and tracking your environment to detect your position. Multi-user environments can occlude the frustum that's exposed by the camera, so that you're moving around in that space and it can lose the tracking.
Right.
So our hope was or Qualcomm's desire was to integrate true 6 degrees of freedom motion in a virtual environment through inside-out tracking.
Right. Which, based on my experience, it looks like you've accomplished that. So, good job. So switching gears a little bit, so it looks like Qualcomm does have its eye on a whole lot more because they're such a large hardware vendor. But it seems like it still ties back to really pushing and getting behind the virtual reality, augmented reality kind of space. So some of that is with recent partnerships with something like Leap Motion. So can you talk about a little bit about like what that partnership is for?
Absolutely. Qualcomm really wants to utilize advanced technologies, and that's not just our own, but any partners that we work with in design and development of our reference design that eventually get incorporated in the final product that's available commercially. And so working with Leap Motion provides a level of experience that is a lot harder to nurture within a company than something that has already been well established as a commercial product. Leap Motion have proven the technology for gesture tracking, and it is something that Qualcomm decided to incorporate into our design because it was such a well-proven technology for gesture tracking.
Right. Maybe you can speak more about like your personal view on it, but right now we have controllers, we have Oculus Touch. So what do you think about the decision to get rid of controllers? Do you feel like that's where we're going?
Yeah, personally, the controller input of virtual reality and augmented reality is the biggest issue today. And having like a true immersive environment where you can just jump in is restricted by any peripherals that are required. Even the headset itself is essentially a device that you have to put on your head, and for any kind of controllers that are in your hands. Obviously, you want the interaction to be fully immersive in that there's no what we were kind of referring to before, but of like gap of evaluation and gap of execution. So the affordance of the tool, whereas a controller always has a low affordance. Like no matter how well it's designed, relative to the natural fluidity of the motion of your hands. So trying to learn a new controller every time you try a new VR headset is very restrictive. Whereas the idea is that eventually with gesture tracking, you'll be able to find a set of interactions that are standard, like a QWERTY keyboard, for example, that everybody knows. And that are able to do like basically kind of like sign language, so that there's a standard that's been established that is sign language, and the intent is to have a particular set of gestures to be standardized for virtual reality.
Right. That makes perfect sense.
Yeah, and then you don't have that gap of evaluation.
Neil?
It's interesting. I was actually looking at what it would take, or if people are building gloves that would be able to translate sign language into text or into a spoken computer voice live. You would think that would be something that exists these days, right? But the fidelity required, and I guess because there's a lot of variations in sign language as well, makes that a pretty difficult task even today. So it really puts things in perspective when you talk about gesture recognition. And there's part of me that wants to say, like, why isn't that problem solved? Shouldn't that be simple by now to just look at my hand and tell what I'm doing and assign that to actions? But it's actually a pretty challenging problem. I will say, though, it's interesting, Nigel, when you talk about removing controllers and even removing the headset and things like that, I agree. I think that the less you have to do to get into one of these experiences, the better that not only the experience will be, but the community around it. I will say, though, the one nice thing about having a controller, for all of its drawbacks, having some sort of tactile feedback is really nice.
Absolutely.
And maybe what I just said right then in 20 or 30 years will be like, oh, you're so old, you require tactile feedback to like understand it. Like, didn't you get the brain waves? Like, you got all the alpha and gamma waves. Why do you need to have something through your skin? What a primitive being. But, but I think that it is a big component right now is, even if in VR I'm touching something, I want to physically, even if the controller vibrates when I play baseball, right? Like that feels like you did something. That's almost giving you a lot more context of the experience. And so you see people trying to do, I think, let's call it airborne haptics, right? Where they're using ultrasound or other things than a controller in your hand, so that it still is from your perspective, sort of clean experience. But I think, I'm curious, sorry, I know I'm kind of going on for a while here, but I'm curious, what you think about removing the tactile experience by removing the controller.
Well, you make a good point about ultrasound. There's an interesting company called Ultra Haptics, and that we got to experience at the AR in Action event about a month ago now.
Yep.
Yeah. And they're actually using ultrasound for tactile feedback. You have a restricted volume of space that you will actually have this tactile feedback in, but they are essentially, I'm not going to explain it perfectly. Obviously, this isn't a technology I'm familiar with, is that they are oscillating the nerves so that you get a sense of touch. And an interesting point, someone mentioned to me from Ultra Haptics is that, for example, when you go to grab something in a virtual environment that might only be a truly virtual object, if you even get the slightest sense of tactile feedback, that's enough to restrict your motion, so that if you go to grab a cup in virtual reality, like a fragile cup, you'll grab it in such a way so that you don't actually break the cup and shatter it. So you'll actually stop at the space around it. And so it's very relative. So you really want some form of tactile feedback, but it can be so subtle that you only need a slight influence to have our minds receive that feedback for our minds to receive that feedback to then interpret the next reaction. So it's very interesting, and I think you're right that tactile feedback is something that's. You won't ever be able to completely remove it, but we'll be able to make it extremely more subtle and then have it more evoked by other cues within the virtual environment, such as the physical actual object being in that space.
I find it so interesting to think, if I want to, to step back and say, okay, I want to give you the sense of picking up a soda can in virtual reality, right? And, on a scale of 0 to 100, how much of your visual channel do I have to satisfy for you to think that happened? How much of your tactile channel has to feel like it's a cup? How much of your ears have to think, have to hear those subtle sounds of you picking a cup up off the table, things like that, right? And where can we cheat a little bit, right? So if it's visually perfect, if the audio is perfect, can we cheat on the tactile and it's just a vibration, right? Something like that. And I think these are the sort of things that we're going to figure out, or that a lot of companies will figure out over the next maybe 5 to 10 years, as immersion is not only visual but the whole body immersion, the whole sensory experience.
With once we fully understand relativity as well, I think that's something that will help us to do these feedbacks, sensory inputs, or I should say outputs, but input into our own personal systems. And one aspect of that is motion for 6 degrees of freedom tracking, for inside-out tracking, is that motion is very relative, so that if you have somebody walking down a straight line in virtual reality, they could actually be walking in a curve in reality, in the physical reality, and they'll have no idea, because everything is so relative. Motion is relative, time is relative, space is relative. So once we're able to understand relativity better in society in general, I think that's something we'll be able to leverage, and to be able to understand how to use relative feedback to have a much more visceral experience in VR.
Right. So one of the challenges I've seen in VR so far is trying to convey weight of an object. Yeah, so if you're trying to throw a can or a knife, that's something that's spinning. Mm-hmm. Then with that, it's very difficult to actually feel how much you need to, how much force you need to do, because now it's relative to the controller and the accelerometers, and you can speak to this more than me, how the hardware is essentially limiting what you can and can't do.
Particularly, there's like a refresh rate, and especially for tactile feedback. Like, for example, our reference design does 70 frames per second, which is better than what's previously been done for mobile experiences. Ideally, we want to get to at least 120 frames per second, but people say that 90 frames per second is generally an accepted value. And that's just the sampling rate of your eyes.
Yep.
Your fingertips have a different sampling rate, and that's what I was getting at in terms of pressure versus texture. And so the sampling rate of the feedback for pressure is required for, truly feeling that weight in the virtual environment.
I see.
Yeah, and so a kind of an example, like to understand this concept of sampling rate, like your eyes can you deceive yourself in reality as well. Like if you're watching a car go down the street, and a wheel of a car accelerates too fast, that it goes past the sampling rate of your eyes, each cycle will get ahead of itself, and eventually the wheel will start to look like it's going backwards. Right. And that's because it's going at a sampling rate that's higher than the sampling rate of our visual perception. So you can cheat in ways like that, right? Because we have a lower sampling rate, you can produce different effects, like causing the wheel to make it look like it's spinning backwards because it's at a faster sampling rate than our eyes can perceive. So hopefully that answered the question that you're asking about weight and pressure, and how that's such a hard, it's just something that's very hard to implement inside a virtual environment.
Yep. Yeah, definitely more than answers that. Thank you.
It's cool. There's, as far as trying to give you a sense of, to some degree, weight, maybe not full-on weight, but at least like the direction of pressure, more than just a haptic response. There's, research towards taking gyroscopes and making them small enough to at least wear in a backpack in the future, assuming certain like physical limitations are surpassed, is to be able to weave them into a fabric, you could imagine, where you'd actually feel directional torque as opposed to just the vibrating back and forth of a haptic feedback that we have now. So you could feel a slight pull down or to the left or to the right. And right now they use these gyroscopes are called control moment gyroscopes.
What was the name again? What was the name again, Neil?
Spacesuits for astronauts, so that when they are in space, they can sort of oppose their motion, effectively giving them a sense of resistance to kind of combat the muscle atrophy that they go through when they spend a long time in space and things like that. So if that technology is pushed forward, it could add to this immersion from a different perspective as well.
It's amazing what industries drive the technology. And like, for example, automotive is really driving heads-up display technology and particular types of rendering for infotainment systems. But really interesting to mention, like, astronauts in space and this feedback. So what was the name of the technology that they were using again, Neil?
So those are called CMGs, which stands for Control Moment Gyroscope.
Okay.
And gyroscopes are basically those kind of spinning discs that you'll see that can create a sense of balance. But what that also gives you a sense of direction, right? And we can put some links in the info of this podcast to a couple of papers or a couple of kind of videos if people want to check out that technology a little bit more.
Absolutely. It's definitely something interesting I'd love to see get incorporated in these feedback systems that are being designed. And I imagine some people somewhere are already introducing that, I would hope, especially if it's been established in an industry like space travel.
Right. Well, yeah, I mean, it is still like new in this industry. So, and then in terms of bringing it to a point where, it's small enough, I think, to enable commercial applications, there's certain like almost, I don't want to say physics principles, but there's very, very hard things that have to happen. But very smart people are working on it. So here's hoping that the future pans out.
Yeah, absolutely. And it's like, as long as the right people are nurturing, that technology in its infancy, like that's really what matters. And that people who are passionate enough to drive that technology. And the hardest part is that there's so many thousands of different types of technologies that we want to incorporate to give ourselves a truly immersive experience. And the regiments for those technologies are even much more stringent for experiences like AR experiences, where you can cheat a lot more in virtual reality than you can cheat in augmented reality. Everything has to be much truer to the natural experience. Even objects that you render in the space have to be more naturally lighted, so you can't, get away with a lot of these optimizations that you do to generate that experience. So AR is going to have a much more strict set of guidelines for for those experiences. And for one of those things is this motion to photon latency, and that it's much more like, for example, our Qualcomm reference design, the motion to photon latency is under 18 milliseconds, but for augmented reality, it needs to be much higher.
So as far as like lighting, like if someone's actually trying to make it to where the shadow is from the same direction as the sun, what kind of hardware would be used to get that information?
So it gets a little bit into light fields and the capture of light fields. And so I'm not sure how much our audience is familiar with ray tracing and path tracing and light fields. And that's to really truly render something with accurate lighting. You need to have three aspects to it. You need the capture of the light field, you need the rendering of the light field, and the display of the light field to be at a point in its for that technology to be at a point of innovation in that it can all. So what I'm trying to say is that not any one of those 3 points, whether it be the display or renderer or I'll go in the right order, whether it be the capture, the render, or the display of that light field, is limiting the others.
I see.
Yeah. So there's a really interesting company in Boston called Lumi, and they're doing some great work with the display, the rendering and display of light fields. And it's really, truly thrilling to see that kind of technology being designed. And they're using static images currently, but like I really want that technology to be integrated into an augmented reality experience and actually have true light field rendering. And by that I mean when you move around in space, that you always get the true rendering of that object, that virtual object. So you want to have, like you said, the light being directed in such a way so that it's casting a shadow accurately. And that's something that you get with path tracing. But the problem is that the complexity of this global illumination that you have for this indirect lighting. So it's easier to get like a direct shadow just through ray tracing, but to try to produce like these soft shadows that we see in reality, it's much harder, much more highly computationally expensive to render those scenes. And it's something that I would love to see be incorporated in augmented reality, but the computational complexity of that is just so high right now. But we could optimize that, to do things to cheat in ways so that you do get a accurate directional shadow, but not a truly the shadow that doesn't project a color intensity, or the opposite of that, the reduction of color intensity for that position, that scene.
I see. So switching gears a little bit, unless Neil, did you have another thing to say there?
No, I mean, this is sort of a side comment. I don't know if this is podcast worthy, but as a side comment, I wonder if it would make, if there would be any interest from the community to put together, at least for one or two events, just like more technical talks related to what's going on these days. Like, someone coming up and giving like a 15 or 20-minute talk about light field technology, someone coming up and talking about, an intro to SLAM and things like that. I don't know, just off the cuff, what do you two think? Would that sort of content be interesting?
So we're in Boston, so we definitely have the population here, especially being right next to Harvard and MIT, that would definitely be interested in that topic.
Absolutely, yeah. And it's hard to, that's what I love about what you guys are doing, and that, you need people to really, what's the right word to use here, to spawn or to just kind of ignite the conversation, and have people come together to these community events and to speak to each other and to learn from each other and to guide each other. And it's something that's so important for the development of these technologies, is for there to exist a community around it which support each other and provide feedback to each other and allow us to progress the technology a lot faster, and something that's definitely very important. And I wish there was more of it. And if it does exist, how do I find out about it? And that's such a difficult task. The first thing when I came to Boston, I looked on the meetups and I found the Boston VR meetup, and it was just in its infancy and it had just started. And so I decided to go to one of those events, and that's when I met all of you guys at the Boston VR. And what's nice about these Boston VR events is the diverse selection of people that you get to meet, and in all kinds of fields and cultures. It's really incredible. I think that's something that's so important, and I wish that was happening for more than just the high fashion technology. So, like, augmented reality is high fashion, VR, virtual reality is high fashion, machine learning is high fashion, and deep neural networks. But there's a lot of these technologies that these technologies are dependent on other technologies, like you're talking about SLAM for motion and tracking, and like other technologies like SIFT, and like it's so important to nurture them. And if they don't have the communities, they just can't get nurtured properly. And so these types of events are so important to the evolution of the technology.
Right. Just
cool. I'll give a shout out where, speaking of being in Boston, being so fortunate to have so many universities around. There's a more technical meetup called Imaging Cafe that meets at MIT, usually at the Media Lab, and that's a lot more computer vision focused. A couple different folks out of the Media Lab and out of the Camera Culture Group run that. I think they're starting to meet more regularly now, and that's a great place to go and get some more like technical exposure to what's going on these days in these different fields besides just the high fashion technology. I like that phrase.
Absolutely. So I'll just give you guys the overview right now. I'll try to make it not too technical. So right now, everything is focused on what we call rasterization, and that's an archaic form of rendering. And by rendering, I just mean drawing the image, drawing the graphical image. And rasterization monopolizes the hardware. So everything is like, you want everything, so it's easy to write everything in software, but you want things to be very accelerated or very performant. So you want to accelerate it through fixed function hardware. And the problem is that all graphics technology today is primarily focused on rasterization instead of ray tracing or path tracing or photon mapping or light field rendering. And it's nice for people to have discussions about where the technology is headed. Yeah, so like don't limit yourself by what the capability, when you're imagining design, don't limit yourself by the capabilities of today's hardware. Think about what the hardware is going to be capable of in the future when you design something, because that will facilitate the earlier adoption of the future technologies. I hope that's clear. It makes sense.
Yeah, that makes perfect sense.
That's kind of like the whole principle with the headset that you guys are making available to developers in a sense.
Yeah, exactly.
Yeah, that sounds like you guys are thinking to the future by building a whole nother headset that is basically, it's from what you've explained, is there to fund the future of virtual reality. And that's like where I want to make the statement that if we're in a car that is this virtual augmented reality car that's taking us to the next generation and future of technology, and then Qualcomm is essentially the engine that's getting us there.
I think that's an appropriate analogy. And that's something that I think Qualcomm prides itself in, and being the core technology behind all forward-facing technologies.
Right.
So everything you see is then powered by a chip that's inside of it. And that's something that Qualcomm is very focused on designing and developing.
And that's one thing I understand about the chip is that, especially when we refer to Snapdragon, is we're not referring to it as a chip anymore. It's the Snapdragon platform.
Yeah. So we have two components to it. We have the software platform, and for virtuality, we have the VR SDK, and that's the software platform for developers to build from. And then we have our system on chip. And the nice thing about that is that it's providing you with the computational requirements, the computational technology that is a requirement to implement future technologies. And our hope is to get that technology in your hands at an earlier date so that you can design the software more appropriately. I think that answered.
Yeah. Makes sense. Neil, did you have something to add to that?
Just maybe, kind of from your 2 cents, based on everything you're talking about in terms of where Qualcomm wants to be in this ecosystem and how they want to position themselves, it actually makes a lot of sense to have sold off Vuforia to PTC. That was maybe like a year and a half ago or something like that now. So maybe two kind of questions from that. One, just your general to your general thoughts about that sale of having happened, and then the Vuporia community was pretty strong actually, and I wonder if that was just because that was the only game in town for a while, or if that sort of community building is something Qualcomm is really good at, and they're trying to do that again now with developers with this hardware, right? So maybe if you just want to comment on sort of the ability to build communities and developer communities specifically.
What Qualcomm really wants to do is nurture the technology. And a lot of technologies aren't necessarily a perfect fit for what Qualcomm has envisioned for the product that we're designing. And if we can nurture a technology to a certain point and to help further it along, then it is sometimes a good idea to then spin off that technology for another industry partner to incorporate in their platform or hardware or software.
Right. And back to software, when is the VR dev kit coming out?
Qualcomm Snapdragon Virtual Reality Software Development Kit is already available today. There's also a hardware accelerator program that has been initiated for people to purchase a subsidized virtual reality device that contains all of the technologies that we've been talking about, and those would be the 6 degrees of freed motion, inside-out motion tracking, things like foveated rendering, and the leap motion gesture tracking. So the core technologies that are in the Qualcomm Snapdragon VR headset, HMD headset, is that we have a CPU, we also have a GPU, and then we also have a DSP, and then we also have a modem, and we have like an audio encoder, an audio decoder, a video encoder, a video decoder, and we also have an image spectral processor which is like for image post-processing. And all these technologies need to be fused together and abstracted in such a way that it facilitates the development of applications, because it's impossible to understand for every developer to understand how to develop for each specific piece of hardware. So the main example is like sensor fusion. So in the device, we also have an accelerometer, a gyroscope, a magnetometer, and then we also have the inside-out tracking through camera systems. And all these technologies, particularly all these motion technologies, we want to fuse together so that then the application can just poll a position and poll at such a frequency that doesn't disrupt your experience. So if that positional sampling rate needs to be high enough. And for example, for the inside-out positional tracking, that's I think 800 hertz.
I see.
And so that means like 800 times per second you're polling the position, and that needs to be at the perfect sampling rate for the perception of motion from your input system in your body. I hope that describes. Yeah. And so what we want to do is define a software platform that facilitates, or a software platform that abstracts all these complex technologies into a software kit that developers can then use to quickly prototype their applications, prototype the designs that they want to implement in an application for virtual reality.
Right, and that comes back to at least a little bit about having to foster these communities to where those developers are even around.
Yeah. So the application developers, they're the content generators. Those are the people who are doing all this amazing design work in terms of these incredible experiences that we're seeing in both augmented reality and virtual reality. And without those communities, you don't get the nurturing of that content generation. And that's something that's very important to Qualcomm. And that's something that I personally have tried to really involve myself in the community so that we see more amazing content generated for our platform. And because it's absolutely incredible, some of these things that are being demoed, even Rotu, who are hosting us tonight, they have a really amazing demo called Pangea, and it's one of the best adventure experiences that I've tried. It's very so one issue about current VR systems is that with outside-in positional tracking is that how do you translate motion in large regions of motion in that space? So, and Rotu have been able to do a teleportation scheme that is very fluid, and just like you're able to jump around the experience and to solve the puzzles that they have in their virtual adventure that is very focused on music and mythology. And
and we definitely want to get them in on the show sometime to definitely go further into that, because they've done a whole lot of work in just creating a world that everything is based on music.
Yeah.
And with that, like, there's so many things they can do as far as, like, the sounds they can create, but then have, like, that tie back in. Mm-hmm. So people's natural reaction when they're in virtual reality is to just start playing with things. And what they've done is they've made it to where you can play with things and you'll get different sounds, because they do a little bit of randomization on, like, which segment they'll take from a sound bite, just so that you get a different sound. Because, in real life, when you hit something, you hit it again, you're not getting the same sound because it's different force. It's not going to be the exact same force.
Yeah.
And it's really impressive what they've been able to do, and it's really awesome experience.
Yeah.
And so I guess we're running out of time for you, Nigel. So thank you for coming on the show. And Neil, do you have any last-minute questions?
No, I think that was great, Nigel. Thank you so much. It was really cool getting a little bit of, kind of a summary of what Qualcomm is doing these days. And, it's pretty impressive, to push the industry forward in that way, to say, hey, developers, here's a glimpse of what the future is going to look like. And then you're able to go to the OEMs with this developer base that's hungry for these features and say, hey, push this forward. That's really cool.
Yeah, and I'm so happy to be part of this community in Boston and Cambridge, and to see all the innovative technologies that are coming out from such a nurturing environment that exists here. And I definitely think it's probably one of the biggest innovation hubs in the world for both virtual reality and augmented reality.
I'm Neil Gupta.
And I'm Craig Herndon.
You can find any info in the show notes. Please subscribe on iTunes to listen again, and we'll catch you in this reality
or the next.
Thank you so much for listening. We would like to keep sharing more about VR and AR with you, so please consider a few dollars to our Patreon, linked in the show notes. The Virtuality podcast is produced by Jason Parks and music by Rachel Dazinski. This podcast is in collaboration with Boston VR and Boston AR. Monthly meetups and events can be found on meetup.com. You can also follow us on Twitter @VirtualityCast and learn more at our website, virtuality.show.